Okay, today I want to talk about geometric distribution, which is different from binomial distribution. Now, when we talk about geometric distribution, it has to satisfy certain conditions. The first condition is that the trials must be independent. Independent, or I can say independently carried out. Okay, so that's the first condition for a geometric distribution. That is, you have the trials, they're not dependent on each other. And then the trials must be Bernoulli. The trials must be of a Bernoulli nature, which means that there must be Bernoulli trials. And therefore, we have either a success or a failure, either a success or a failure. And the third condition is that the probability P, okay, of a success must be the same for each trial, must be the same for each trial. Okay, now maybe we're going to define a geometric distribution, which is basically denoted as follows. So X is geometrically distributed with a parameter P, where P is the parameter. And also we know that if P is our parameter, P is our probability of success, then the probability of failure, which is the same as for, like we met in binomial distribution, is going to be Q, which is 1 minus P. So, and also it must be noted that X cannot take value 0. Well, then also we need to note that although the number of trials could be infinite, number of trials, okay, could be infinite. But this is, in practice, it's very unlikely, okay? In practice, it's very unlikely. Okay, we want to be reasonable here. All right, and now that's what I can say about geometric distributions to start with. Okay, so I think the best way is just to take an example to be able to understand this more clearly, right? Okay, here is an example. A fair die is thrown and the number of throws it takes to show a 6 is recorded. Calculate the probability that it shows a 6 on the 4th throw. That means if it shows a 6 on the 4th throw, the previous 3 throws, it never showed a 6. So what we're going to do is we're going to answer the question by saying probability of X is equal to 4. So basically on the previous 3 throws, it did not show a 6. What is the probability that it shows a 6? Probability that it shows a 6 is going to be 1 over 6. Probability that it doesn't show a 6, okay, X is not equal to 6, is going to be 5 over 6. So we have then 5 over 6 times 5 over 6 times 5 over 6 times then the 4th row, first, second, third. The 4th throw, it shows a 6. It shows a 6 on the 4th row. So the 4th row is a 1, first, second, third, and then 4th. It shows here as 6. So when you multiply this, basically what we're saying Q to the power 3 times P, which is basically 5 over 6 to the power 3 times 1 over 6. That's the formula. And so this is going to come to 0.0965 from your calculator. And of course, now we're going to move on to the second part of the question. Now, the second part is very interesting because there's a formula to that effect. And I want to talk about this formula here. So really what I want to talk about is let us understand what we actually mean by saying that probability of x is less or equal to x. We are saying that this is the probability of success in the first x trials. This x here, x trials, okay? Let's just suppose I say probability of x less or equal to 5. I mean 1 plus 2 plus 3 plus 4 plus 5, and I'm getting successes in all those trials, okay? But if you want to take this further, the probability of success in the first x trials, okay, would you agree with me, is basically probability of x being less or equal to x, which is probability of success in the first x trial. And we can get this by saying that this is 1 minus the probability of no success in the first x trials. No success in the first, okay, x trials. So 1 minus no success is going to give you success, all right? So there we go. This is quite logical in that sense, okay? So that's what I want you to understand. Now from here, what we're saying, we can take this further by saying 1 minus, what's the probability of no success? When we say no success, we means q to the power of x. So this is q to the power of x. Now from here, it's going to follow that if I want the probability of x being greater than x, which I'm sure now you will refer to this question here. Okay, we did say it shows a 6 after more than 2 throws. It shows a 6, a success after. Okay, this is after more than 2 throws, more than 2 throws. So what are we saying? We're saying probability of x being greater than 2. And this refers to probability of x being greater than x, which is 1 minus the probability of x being less or equal to x. Okay, so if we do that, then we're going to get 1 minus probability of x being less or equal to x, which is this, 1 minus q to the power of x. So 1 minus q to the power of x. And here is what we're saying. The 1 minus the 1 cancels out, and the minus minus becomes plus. We have q to the power of x. So what we're saying is that, let me just rewrite this. Probability of x being greater than x is equal to actually q to the power of x. So what, from this example here, probability of x being greater than 2 is going to be q, which is 5 over 6. That's our probability. We did say q is 5 over 6 over here, to the power of x, and x is 2. So this, if we do that in a calculator, we should be able to get 964. So you see, the reason I want to lay stress on this formula, this is what I'm talking about, because it saves times in the exams. Because imagine if you were to calculate the probability of all of that and then just add them up and whatever the case may be, and then take one, subtract this, and then go again and take one, subtract what you got here to reach this, it's going to be very time consuming in the exam. So the best way is to remember how to do this, to bring up the formula so that you can use it for the exams. And basically what I'm saying is probability of x being greater than x is equal to q to the power of x. I know you've got lots of formula to remember, and this is one of them, but if you just know how to go about and bring the formula back to memory, it's going to be in your advantage when it comes to the exams. I hope that this has been of help to you. Thank you for your attention and take care.